Hello everyone. In this video, I will be solving GATE 2018 Chemistry question number 40. This question states that for an inverse spinel AB2O4, the A and B respectively can be. So before moving, we have to look what are actually spinels, inverse spinels, and how to identify inverse spinel. So spinal structure is a series of compound having combination of two oxide so it is a mixed oxide of divalent and trivalent metal ion. Okay, by saying divalent, that is A plus 2, it will form oxide AO, and a trivalent metal ion like B plus 3 will form oxide B2O O3. So my spinel will be AB2O4. Okay. Now there exists two type of spinel. One normal spinel and other one is the inverse spinel. So for normal spinel, the spinel structure is such that the oxide ions are arranged in CCP is such that oxide ions are arranged in cubic close packing CCP, and divalent ion is present in 1/8 of tetrahedral void, and the trivalent ion is present in half of octahedral void. Okay, so this is the normal spinel. We can uh, write it as this: A, which is a divalent, it is present in tetrahedral void. B, which is the trivalent metal ion present in octahedral void with a O force. Similarly, in inverse spinel, so in inverse spinel, what will be my trivalent ion gets distributed equally among octahedral and tetrahedral void, okay, and my divalent metal ion, that is A, is occupy the octahedral void, okay. So here my trivalent ion is equally distributed between tetrahedral and octahedral void. Okay, so to distinguish between these two, uh, to identify the spinel, we take the help of crystal field splitting energy, that is CFSE. So we calculate the CFSE of both the metal ion, that is divalent and trivalent, and then compare these two such that if my B plus 3 CFSE in octahedral field, if it is greater than the CFSE of A plus 2, it will be a normal spinel. So similarly, if the CFSE of my trivalent metal ion is less than the CFSE crystal field splitting energy of my divalent metal ion, then it will be a inverse spinel. Okay, let's just note some tips. Number one, that the CFSE of a non-transition metal is 0. And number two, if both A plus 2 and B plus 3 metal ion are non-transition metals, then they belong to normal spinel. Okay. Now, talking about the crystal field splitting energy, CFSE, in octahedral field, here, because it is a oxide, mixed oxide, so we have a weak field complex, it will be a high spin complex. So our metal will experience, it will be a high spin complex or a weak field complex due to the weak field ligand. And since my O4 occupied the CCP structure, that is why it is a octahedral field. So the splitting energy for the octahedral field for D, it will be something, it will be like, so the splitting energy for D orbital in octahedral field is, this is DG, this is T2G, this is D orbital, D orbital, this is my energy. So this is dxy, dyz, dzx, and this is dx square minus y square and dz square. Okay, and the energy is, this is uh, 0.4 minus 0.4 del naught, and this is plus 0.6 del naught. Okay, so for the given metal ions for our question, we will find CFSE one by one, and then we'll determine which one is the inverse spinel. So first of all, nickel 2 is, the electronic configuration will be written as argon 3d8, and for gallium 3. This is actually a non-transition metal. So this has a CFSE 0, and this one is definitely having CFSE minus 1.2 del naught. Correct? Yeah, so we have nickel plus 2 CFSE greater than gallium plus 3, and for this one belongs to our inverse spinel. Okay, but let's also have a look on other combination like zinc 2, that is, the electronic configuration is argon 3d10. It has a CFSE of equal to 0, and Fe3, this has the electronic configuration as argon 3d5. It again has a CFSE as 0. So in this case, actually both are the transition metal, no, transition metal, and having CFSE equal to 0. Now we will go by size. So zinc has a smaller size in comparison to Fe. Okay, so zinc plus 2 will occupy the smaller void, that is the tetrahedral void here, and hence it will be a normal spinel. Okay, and third is Fe2 and chromium 3, and similarly you can find that the Fe2 electronic configuration is actually argon 3d6 having CFSE 0.4 del naught. Okay, with chromium having electronic configuration 3d3, so CFSE is uh, minus 1.2 del naught, and hence it is again a normal spinel. Okay, because my divalent CFSE is larger than my trivalent metal ion. Okay, in the last case, Mn and Mn3, so my Mn2 is actually argon 3d5, and my Mn3 is actually argon 3d4. So this becomes CFSE equal to 0 and D4 is 0.6. Okay, so again this one is a normal spinel. Sorry. Okay, yeah. Because why? Because it has a higher CFS. So the given question has asked us about the inverse spinel among the given option. So we find out that the option number A is the correct one for the inverse spinel. And for this particular topic, I will highly recommend you to go through the lecture for lecture number 48, Perovskite and Spinels by Professor Madhav Ranganathan, Department of Chemistry, IIT Kanpur. I have also attached the link below. Thank you.